Alright, welcome guys to another video. Now we're working question 8 from the June 2019 CSEC Mathematics paper 2. And we'll start. It says the function f and g are defined by f of x is equal to 9 divided by 2x plus 1 and g of x is equal to x minus 3. And it says state a value of x that cannot be in the domain of f. So we're stating which value cannot be an x value, a domain value here. Basically we're making this expression, this equation undefined. So what we know is that at no point should the product here work out to be 0, as we cannot divide 9 by 0, as that will make the entire function undefined. So what we know is that 2x plus 1 is equal to 0. So we're trying to find which number cannot be used in the domain. So therefore 2x is equal to 1. So we're solving for x, and this should actually be a -1 as it was adding on the right hand side. So when it comes across, it will be subtracting. So it is 2x is equal to -1, and therefore x is equal to -1 divided by 2. So therefore x is equal to -1/2. So therefore this -1/2 cannot be in the domain, as it will make the function undefined. And if you're wondering, should you put in your calculator 9 divided by 0, you'll see that it says math error. So if we should look at it, you'll see equal 9 divided by 2, and we're replacing the x with -1/2 plus 1. So now when you look at it, 2 multiplied by -1/2, what we'll get is 9 divided by, this would now become -2/2, which would be the same as -1/1, which will leave our answer to be a -1. But let us show the full working. So it will become -2/2 plus 1. And now if you look at this -2/2, as I was saying, it will become 9 is 9 divided by -1/1 plus 1. And now from this -1 divided by 1, what we'll have is 9 divided by -1 plus 1. And now when you do that, you'll have 9 divided by 0, as -1 plus 1 will leave us with 0. Now if you put this in your calculator, what you will get is this coming up. You will have math error. So therefore at no point in our function can x be -1/2, and we just prove that. Part 2 now says find in its simplest form expressions for f g of x. So what this is saying is that wherever in f we see x, we will replace it with g of x. So writing back the terms just in case you don't remember, f of x was equal to 9 divided by 2x plus 1, and g of x was equal to x minus 3. So now wherever in f we see x, we will replace it with a g of x. So the terms x minus 3. So what that will look like is f of x is equal to 9, and that is divided by 2 then g2, and wherever we see x, we're going to replace it with g of x. Basically, I'll write out the terms shortly, and then plus 1. So that is basically what we are doing. So wherever we see x, we replace it with g of x, and this is composite functions. So now writing out g of x to replace it with x minus 3, which is the actual terms for g of x. So therefore, f of x is equal to 9 divided by 2, which is multiplied by x minus 3 plus 1. So now working out the bracket there, so we'll have 2 multiplied by x and then 2 multiplied by negative 3. So f of x is equal to 9 divided by 2 multiplied by x will give us 2x, and 2 multiplied by negative 3 will give us a negative 6 plus 1. And now looking at that, what we'll have is f of x is equal to 9 divided by minus 6 plus 1 will leave us with a minus 5. So what we'll have is 2x minus 5, and this is our answer in its simplest form. Part B now says f inverse, so f of x inverse. So basically what this is doing, how I work it, is usually write the function. So f of x is equal to 9, which is divided by 2x plus 1. Then what I do when I'm working this is to, right now we know f of x is the same as y is equal to 9 divided by 2x plus 1. Then I do the change from here. So next what we do is to change the y to x and the x to y. So the inverse is already being done here. So our final answer will be the answer that is needed for the question. So what we'll have is x is equal to 9 divided by 2y plus 1. And now what we go ahead and do is now solve for y. So we're making back y the subject of the formula. So what that will look like is we'll now have 2y plus 1 being removed from the denominator portion to the left-hand side of the equation. What that will look like is x being multiplied by, as it was dividing here, so it will be x multiplied by 2y plus 1 is equal to 9. So now working out that using distributive law, x multiplied by 2y will give us 2xy plus x multiplied by 1 will give us 1x, or x, either way that you choose, is equal to 9. So what we're doing now is to solve for y, we're making y the subject of the formula. So what we'll have is we're moving the positive y from here to bring it across. So it was adding here, so when it comes across, the positive x, when it comes across, it will now be subtracting. So it is 2xy is equal to 9 minus x. So we subtracted x from both sides of the equation. And then we have, now we're removing the 2x basically from this side of the equation. So it was multiplying here. So when it comes across, it will be dividing. So it's basically dividing both sides of the equation by 2x. So it is y is equal to 9 minus x, which all of that is divided by 2x. and this is our answer. So that is what I'm saying. When we work it this way, this basically gives you the answer in the format that it needs to be. So it will be f inverse of x is equal to 9 minus x divided by 2x. So instead of doing the inversion or changing any signs at the end, you change it at the start. So when you're working through your final fraction that you get, or final terms, or final equation, or final expression is your final answer. So it is 9 minus x divided by 2x. And in this case, we know that at no point x cannot be 0, basically. B says the diagram below shows two rectangles ABCD and GFED, and ABCD has an area of 44 centimeters square, and GFED has 4 sides, 4 centimeter and 2 centimeters. So 4 centimeter on 2 sides, 2 centimeter on each side. And AG, which is right here, is equal to EC, which is 3x centimeters. So it says by writing an expression for the area of rectangle ABCD, which is the bigger rectangle, show that x squared plus 2x minus 4 is equal to 0. So we're writing an expression for the area of the rectangle. So what we know is that area of a rectangle is equal to length multiplied by width. So therefore, the length of this rectangle would have been, so we're looking at the length of AD and the length of DC, as is those two parts that will give us the area. So it would have been equal to 3x plus 2, and this is multiplied. So this is one of the terms. Let's call it the length, and the width we're using 3x plus 4. So it is 3x plus 4. So when we work that out, what we're doing first is saying 3x. So let me get my pencil to show exactly. So what we're doing is 3x multiplied by 3x, then 3x multiplied by 4, then 2 multiplied by 3x, then 2 multiplied by 4 in working out the area for this. So it is 3x multiplied by 3x, and that will give us 9x squared, and then 3x multiplied by the 4x, that will give us plus 12x, and then 2 multiplied by 3x will give us 6x, and 2 multiplied by 4 will give us 8. Now doing some amount of simplifying. Next, what we have is 9x squared and 12x plus 6x, that will give us 18x plus 8. So therefore, what we know is that the area which they gave us up top of the big triangle was 44. So therefore, area which was 44 centimeters square would be equal to 44 is equal to 9x squared plus 18x plus 8. So therefore, 0 is equal to 9x squared plus 18x plus 8 minus 44. As the 44 was adding here, so when it comes across, it will be subtracting. So it is 8 minus 44, and we can work out that part to simplify. So therefore, 0 is equal to 9x squared plus 18x and 8 minus 44. That will leave us with negative 36. From this, what we can see is that all terms, they have a common factor in it, which would have been 9. So what we can do to simplify is to say divide throughout by 9. And what we'll get is 0 is equal to x squared, as 9x squared divided by 9 will leave us with x squared, plus 18x divided by 9 will leave us with 2x, and 36 divided by 9 will leave us with 4. So therefore, 0 is equal to x squared plus 2x minus 4. Now, if you look at, that is what the question asks us to prove that x squared plus 2x minus 4 is equal to 0. And that is exactly what we did here, x squared plus 2x minus 4. So look, x squared plus 2x minus 4, x squared plus 2x minus 4. So that is exactly what we did. So part 2 now says calculate to 3 decimal places the value of x. So we'll need to use now the quadratic formula for this working. So this is the formula for quadratic. So this is what we are using to solve this question. So from what we knew above is that if we're lining up ax plus bx plus c under this, which is the quadratic equation, we can now substitute for each value that is in this expression. So we know what b is. B is 2. So we can substitute those b. So b is 2. We know what a is. A is 1 and c is negative 4. And we know what a is again down here. This will be 1. So it is working this out to then get to our final answer to calculate the values for x. So when we do that, what we know is that right here, 2 squared will give us 4, and 1 multiplied by negative 4 will leave us with a negative 4. So we now have 4 multiplied by negative 4 there, and 2 multiplied by 1 will leave us with 2 there. And now for this part, what we're working is 4 multiplied by negative 4. So a negative 4 multiplied by negative 4 here, this will now give us a positive 16. So this negative 4 multiplied by negative 4 will give us a positive 16 here. So that is all we're working in this part. And now what we know is that 16 plus 4 will give us 20. And that's what we will work right here. 16 plus 4 will give us 20. And we can now go ahead and find the square root of 20. So when we find the square root of 20, that will be 4.47. let's put it 4.4721. So it is this now that we're going to split into two to then, this is what we're now going to split into two to determine the two possible values for x. One being 2 plus, so it'd be 2 plus 4.4721. So let us put it, so this is our first x value. So when we work that out, what we'll get is x is equal to, so when you do negative 2 plus 4.4721, that will give us 2.4721 divided by 2, and what we'll get is 1.236, and it says to write your answers to 3 decimal places. So that is our first x value. So now looking for our second x value, it will be, so now here our x, which is our second x value, is equal to, so this one will be the negative 2 and this will be minus. So now what we'll have is x is equal to, so it is minus 2 minus 4.4721, and that will give us a negative 6.4721, and we divide that by 2, and what we'll get is negative 3.236, and this is our second x value. So we have successfully calculated the value for x correct to 3 decimal places. Now just going over a bit, so this right here is our quadratic formula. We substitute for each value. So from our quadratic equation, we know that this is A, 2 right here would have been our B figure, and this is C. So this is what we substitute into each letter here. And that is it right here. Then what we did was to say 1 times negative 4 will give us a negative 4, and 2 times 1 gives us a negative 2 here, and 2 times 2 gives us 4 right here, so 2 squared. After we do that, then negative 4 multiplied by negative 4 will leave us with a positive 16 here, as we know that two negative numbers being multiplied by each other will give us a positive number. Next thing what we do was to say 4 plus 16, that gives us 20. And next what we did was to find the square root of 20, which gave us 4.4721. And then what we did in the final stage, there's nothing more to simplify, so we now go ahead and split our equation using this sign right here, the plus or minus sign right here. So one gave rise to the equation being split to give negative 2 plus, and then the other was the minus sign. So we split that plus or minus sign right here to solve for the two possible values for x. Part 3 says calculate the perimeter of the unshaded region. So what we know is that from looking at this side of the rectangle, so this side is basically 3x plus 4, so the 3x right here plus 4 gives the entire length of AD, so therefore BC is 3x plus 4. This DC would have basically been 3x plus 2, so therefore AB, which is opposite, is the same thing, 3x plus 2. And we know that this is 4 and 2, so right here is 4 and right here is 2. So this is what we're doing to calculate the unshaded region. So it is a 3x plus 2, 3x plus 4. We're using 3x here, 4, 2, and 3x from this part. And that these are the terms we're using to calculate the unshaded region. So it will be 3x plus 2 plus 3x plus 4 plus 3x plus 4 plus 2 plus 3x. So what we're going to do is to group all our like terms together so we can work them out. So what we'll have is 3x plus 3x plus 3x plus 3x, and then we'll have plus 2 plus 4 plus 4 and plus 2. So what we have is 3x plus 3x, that's 6, plus 3x, that's 9, plus 3x, that is 12x, plus 2 plus 4 is 6, plus 4 is 10, plus 2 is 12. So therefore, the perimeter for the unshaded region right here is 12x plus 12. But remember, up above we had calculated two possible values for x figures, one being 1.236 and the other being negative 3.236. What we're going to do is use the positive integers. We know that x must have been a positive number. So remember, so this is just one continuous question going straight throughout. So therefore, we're going to use x. So we're now substituting x for 1.236, which we had calculated. So therefore, the perimeter of the unshaded region is 12 multiplied by 1.236 plus 12. When we work that out, it is 12 multiplied by 1.236. We get 14.832 plus 12. And when we do that addition, what we'll get is the perimeter being 26.832 centimeter, remembering our unit. So that is 26.832 centimeters is our perimeter. And that is our final answer. So thank you for watching. Thank you for staying tuned, and we'll see you in question 9.